Hey folks, so this is the third video in section 14.3. This is continuing with Pythagorean Theorem examples. So this says that we should find the diagonal measure of the TV screen. For the sake of the video, I did make the numbers a little bit nicer both on this question and the next question. So just be aware if the numbers are different on your printout, that's why. So the diagonal of my TV screen can be found by using the Pythagorean theorem. This is very much like the first question I did on the first video. So once again, I need to figure out which are legs and what is the hypotenuse. And so I'm going to use my Pythagorean theorem. Both of my legs are 34 and 24. So I'm going to plug that in. So leg squared plus leg squared is going to be 34 squared plus 24 squared. And that's going to equal my unknown squared, which is my hypotenuse squared. So we do a little bit of math, and you see all of my scratch work over on the left side of the screen. So 34 squared is 1156, 24 squared is 576. Add those together, you get 1732. And then we're going to take the square root of both sides. Now I know that this is ugly, but nonetheless, it's really not that difficult. So what I did is over here, I just simply wrote down my 1732. And I said, I asked myself what would be a perfect square that's lower than 1732. My first thought was 1600 because 16 is 4 times 4. And if I have 2 more zeros, that's going to be 40 times 40 to give me 1600. And so then what you can see in my scrap work is I said, well, what's 41 squared? Can I get even closer to that 1732 mark? So when I did 41 squared, you'll notice here that I came up with 1680, which was closer to my 1732. Not only that, then you see that I took that a step further and went to 42 squared, and I got 1764, which is on the other side of that 1732. So that now I can see that my two numbers here, 41 and 42, I know that the square root of 1732 is somewhere between 41 and 32. Sorry, 41 and 42, excuse me. So now the next thing I need to do is I just need to make it a little bit more understandable. So this is going to be 41 point something. My diagonal part of my screen is 41 point something. And so if I'm just doing some guesstimation, I can see that between these two, there's approximately 52 units. But then to get from here to the next one, there's a little bit more than 30 units. And so since this is closer to the higher value, I'm going to go with a decimal that's past 0.5. So I'm going to just make a guesstimation of 41.7 inches. Then I want to look at the Great Pyramid of Cheops. I don't even know if I'm pronouncing that correctly. But also I'd like to point your attention to, I do have a Pythagorean Theorem game. You might want to try that out. You can highlight the link or just follow it there in D2L. So how tall is this? And so I've cut out a slice of right triangle and I drew it down below. And the first thing that I want you to understand is that F is in the center of the pyramid, the floor of the pyramid. So from point F to point D, this is going to be 600 divided by 2. Since the whole entire thing is 600 units, we want to split that in half. So that's where I got that 300 from, that goes from point F to point D. And I now want to find the height, or how tall it is. So this is the distance from point E to point F. I can use the Pythagorean theorem to do this. Of x squared plus 300 squared equals 700 squared. And then from here I can just do some math. So 300 squared is 90,000. 700 squared is 490,000. Combine your like terms, and you'll end up with x squared equaling 490,000 minus 90,000, which is going to give me 400,000. Let's go ahead and take the square root of both sides. If I take the square root of both sides, this is where I want to set up a guesstimation. So what would be underneath 400,000 that would be a perfect square? Well, I thought of 360,000 because 36 is 6 times 6, and with 4 zeros, that just means I'm going to have 2 zeros being squared. So that one was pretty easy. And the other one that I thought of was 490,000, and I know that that one's 700. So at this point, instead of going closer and closer and closer, we're just going to get an approximation of how tall this pyramid is. And when I look at the distance between the two lower ones here, I see that I'm about 40,000 away. But then when I look at the distance between the two upper ones, I'm 90,000 away. So this is definitely closer to the lower number. And so what I did was I just guesstimated that it was about 630 feet tall. It's close. It's not accurate completely, but it is a good approximation.